This video shows a test bench designed and produced by the University of Pisa in collaboration with the ACTA Srl company for testing drill pipes under rotating fatigue. Patent by the University of Pisa on this testing methodology is introduced and described, and a patent demonstrator is presented. The drill pipe section to be tested is placed on two supports which sustain the weight by a tension belt system. Although the eccentric mass is limited in size, the rotating speed is brought to near but lower than the first natural frequency, namely the resonance of the tubular structure. A portion of a drill pipe, such as that including the connection region, can be tested on our bench by attaching two masses at the extremities, one fixed and the other rotating with a certain eccentricity. The bending amplitude is monitored by means of strain gauges and non-contact lasers for detecting the vibrational displacements. The working frequency is initially increased up to the target stress amplitude. Closed-loop control allows to keep a fixed stress amplitude or to change the stress to be imposed just by modifying the working frequency. The frequency of the testing is approximately 25 Hz, and the strain gauge and laser signals are sampled at higher frequency and closed-loop controlled. As the frequency is imposed closer to the resonance, the stress amplitude increases, and the nodal position moves away from the rotating mass, and vice versa. Whenever the imposed alternating load is required to be changed during the test, such as for block loading fatigue experiment, the frequency is slightly modified. However, this implies a repositioning of the vibrational nodes, especially the one close to the rotating mass. After a certain number of loading cycles, either at constant amplitude or block loading repetitions, the fatigue crack nucleation can be observed from the external surface of a drill pipe, or from the thread connection for a specimen with tool joints. The crack then propagates perpendicularly to the pipe wall thickness. The crack initiation is usually at the maximum bending, especially for plain tubular specimens, while for the connections, the usual location is at the so-called first engaged thread.